Hi viewer, this is EasyElimu channel. I'm Vincent Kanmoya and today I'm going to take you through Form 2 Mathematics. We are going to learn about gradient and equation of straight line. Stay tuned as I welcome you all. Let's learn more about gradient, and today we are going to consider a local construction worker who wants to transport some of the construction material from the ground to the top of a wall which is 3 meters high, and he has two ladders, one which is 2 meters away from the wall, placed 2 meters away from the wall, and another one is placed 2.5 meters away from the wall. Now we need to calculate the steepness or the slope of each ladder, taking in mind that of 2 meters away from the wall being ladder 1 and the other one being ladder 2. Which ladder will be more steeper than the other if used? So we shall find out that to find the steepness of this ladder 1, then it shall be steepness of ladder 1 will be equal to the vertical height, which is 3 meters, divided by the horizontal distance which we have to take as 2 meters, and you will find it is 3/2, which is equal to 1.5. So you will find out that this ladder here, its steepness is 1.5, and the other one which we are referring to as ladder 2, its steepness, this was for 1, so the steepness of ladder 2 is 3 meters, which is the vertical height. If we divide it with the 2.5, we are getting, this one gives us a steepness of 1.2. So we can see between the first ladder and the second ladder, we can observe that the first ladder is much more steeper than the second ladder, whereby this one has a more steeper slope or a more slope than the second ladder. So meaning that the construction worker is likely to take ladder 2, since he will not use much more energy on climbing it as when he uses ladder 1. So meaning the one which is likely to be used is 1.2, the one with the steepness of 1.2. In the same way we have found the steepness of that, we can still find the steepness of given lines or straight lines of certain equation, and the way we evaluate the steepness is what we are referring to as finding its gradient. So here the measure of the steepness is what we are calling the gradient. The measure of the steepness of a given, let's say a given distance, with regardless to horizontal and its vertical height, then that is what we refer to as gradient. The same way we have measured, we can still measure the gradient of straight lines or equations of straight line using the same technique. For example, we can have a Cartesian plane in the form of whereby we have a straight line running from the origin, passing through the origin, straight line passing through the origin, and having a vertical unit from, that's why this is y-axis, x-axis, and that line passes through point, let's say this point here is 0.5, or let's say 10.5. And here passes through the origin, and you have been asked to calculate the steepness or the slope of that line. So you will find out that if you have such a line, you will find the vertical displacement or the vertical height is resemblance to the units in which the line has been displaced to that point, if it is P, with regardless to y-axis. So you will find it is at 5 units. So this will be 5 units. The same applies to the x-axis. So you will find the displacement with the x-axis is up to 10 units. So from 0 to here 10 to that point P, you will find is 10 units, and that of vertical is 5 units. Meaning that the gradient, which is abbreviated as grad, can be obtained by taking the vertical displacement or vertical distance over the horizontal distance. And this one can be given by, since we have this one, we can observe that the vertical distance is 5 units, because you will take 5, subtract the origin, which is 0, and you will find the corresponding value will be 5 in vertical distance, and that in the horizontal distance will be 10, subtract the origin 0, because x-axis, x will be 0 at the origin, and you will find the corresponding value being 10. If you work out, you are going to find that your gradient of that line will be equal to a half. That is how we do find the gradients of given lines running through the origin or in a Cartesian plane. Only by identifying 2 points on that line. After identifying the 2 points on that line, just construct any 2 vertical and horizontal lines joining the 2 points, then you calculate the gradient of that point. We are going again to learn more about it, and now we are going to determine the gradient of a straight line using points. So we have, that is like an example. We have an example in such a way that we need to determine the gradient of a straight line using points P, which is -3, -6, and the other one is B, having points 2, 9. We need to determine the gradient of a line, is a straight line passing those 2 points. So on just demonstration or on a sketch, you will find that our line may be passing through something of that sort, such that if here is 2, here is 9, so this point here may be 0.29, which is B, and the other one here be such that it is, this point is P and is -3, -6. So those are the 2 points. So we need to determine the gradient, and determine the gradient, this is what we need. We need this steepness. So we can find the vertical displacement and also the horizontal displacement. So we need to determine the steepness of this line there. And determining the steepness of that line, what we just do there, we are going to find the change in vertical distance over the change in horizontal distance. So meaning that to get our gradient, we shall take the change in vertical distance, and the change in vertical distance will be the change in y, which will be, y here is being represented by coordinates 9 and -6. Since if you write P as this, it is normally written in this condition, such that the first point represents the x coordinate and the second point represents the y coordinate. So that means we shall take 9 minus 6 over 2 minus -3. So that is what we are going to have as the gradient of that line. So in doing so, we are going to have that one as 15, and the denominator will give us 5. So if you evaluate or compute the gradient of that line, you are going to find the line has a gradient of 3. And in most cases, gradient has no unit. For these cases where we are dealing with equations of straight line. So we shall represent it with gradient of 3, representing that is the gradient of the line which passes through point P and B, as we can see from that. In general, we can say that in case we have point P, which is xy, x1, y1, and point Q, which is x2, y2, and it is in such a way that we have a line passing through point P and point Q, and you'll be asked to find the gradient of that line. It's just simple to find. You just take the change in y over the change in x, which you will find, because we said the gradient is obtained by taking the vertical distance over the horizontal distance, and here the horizontal distance will be resembling that change in x-axis. So we shall have change in y over change in x, and that can be written as y2 minus y1 over x2 minus x1. If you do that, whatever you will find is now the gradient of that line, and that is how we do find it out. So you can compute other given gradients using the same technique. So meaning that you can find the gradient of a given line so long as you have been given the points through which that line passes through. If the points are not given, then you can extract the points from the line if it has been drawn on a Cartesian plane. So we are going to next category, whereby we can identify the kinds of gradient to which we can find. For example, if we have a Cartesian plane and be in such that we have lines or straight lines running in this condition, you will find that the lines which runs from left side to right hand side, in case you have drawn your straight line and you find it runs from left to right or right to left, you will find that on evaluation, this line will have positive gradients. Those lines which run in that category have positive gradients, such that an increase in x also leads to an increase in y. If you have lines running from your top left hand side to bottom right hand side, you will find out that if you evaluate the gradient of those given lines, you will find the gradients of those lines are always negative. Simply because an increase in x, if you have an increase in x, if there is an increase in x, you will find there is a total decrease in a corresponding decrease in y. Such lines will give you a negative gradient. So meaning that if you compute the gradient of those respective lines or straight lines, you will always get a negative gradient. But sometimes you will find there are some lines which run horizontal or parallel to x-axis, in that an increase in x have no effect on y, such that if there is an increase in x, y remains 0 as x increases. Such lines have a gradient equal to 0. The gradient of that line is 0. So meaning that the gradient of lines which are horizontal to x-axis is equal to 0. But those which have lines or which lines are running vertical to x-axis, meaning that they are parallel to y-axis, you will find that those lines will have no gradient, or its gradient will be undefined, because there is no increase in x. X remains the same, but there is increase in y, or a decrease in y does not have effect in x. Such lines will have no gradient, or the gradient of those lines is undefined. But if the lines have an increase in x, but y does not increase, as I have said, the gradient will be equal to 0. We shall see some of them as we shall be computing some of the gradients of straight lines in our next session as we continue on. We are going to see equation of a line, and we shall start in case we have been given 2 points. For instance, we have point A as 1, 3 and point B as 2, 8. And you'll be asked to find equation of a line through the points A and B if the gradient is equal to 5. So you have been given this, and you know you can calculate it out even if you haven't been told. So if you haven't been told but you have been given the 2 points, you can still find out the gradient. So the first thing you need to do here, if you have 2 points and you have been told to calculate an equation passing through the 2 points, first thing to do, find the gradient of the 2 points, such that you will have gradient will be equal to change in x, change in y, which is change in y-intercept. I will write it in short form. We do write it in this way. So it will be change in y over change in x. So if I do that, I will find out that change in y will be change in b minus a, which is the coordinates of y minus that of y in a, which is 8 minus 3, over the coordinates of x, change in x coordinate, so it will be 2 minus 1. And you will find here that we are going to have 8 minus 3, you will find your answer is 5. And 2 minus 1, you are going to get the value there as 1. So meaning that the gradient of a straight line passing through point A and B is equal to 5. So having that one as the gradient equals to 5, and you have point A and also point B, we can still find an equation of a line which passes through that 2 points, having the gradient now as 5. So your next step here is to select a point on the line which passes through point A and B, but is not point A, or is it point B, such that if you have your Cartesian plane in this form, and you have that line passing through there, and in such a way that the gradient of this line, gradient equals to 5, but point A may be at this point, whereby we have A, 1, 3, and 2, B is 2, B is 2, let's say this point is 2, 8, this point B. At this point we have B, and this point we have A. In such a condition, we can select another point such that we have that one as here, which is P, on the same line, and say that point has coordinate x and y. If we have that one, we can now say, since we have said that to find the gradient of a given line is equal to change in y over change in x, then it means that if we select one of the point here, we can use it with either a point A or B, such that we can find the same gradient by either relating point P to A or P to B. We can choose one here. Let's choose point A, but N of it will work. So if we choose A, we can say that if we want to find the gradient which is equal to 5, we can find it by taking the coordinates of P minus that of A. So if that is the case, we shall take the y coordinate in P, which is y, minus the y coordinate in A, which is 3, over the x coordinate in P, which is x, minus the x coordinate in A, which is 1, and we shall find that this one arises to, we shall find it as, this one is the same as writing 5 over 1. So if we do that, we can cross multiply, and on cross multiplication, we are going to have 5 into x minus 1 is equal to y minus 3. If we expand the bracket, we are going to have none other than 5x minus 5 is equal to y minus 3. If we need to take one of it to be, or the y to be the subject, then we shall add 3 on both sides to eliminate 3 on the right hand side. So on doing that, we are going to end with y on the right hand side as 5x minus 2. So we have found that the gradient of a line which passes through point A and B is actually the equation of a line which passes through point A and B and have a gradient of 5 is y equals to 5x minus 2 on computation. The same approach can apply to any given points. If you have been given 2 points on a straight line and you'll be asked to find the equation of that straight line, the same approach which we have worked out still works for every given point so long as they are on the same straight line. Now, here we need to consider in a way that if you have been given the gradient of that straight line and one of the point. For instance, you may be given in that the line is having the gradient for example, is 4, and one of the point, let's say point A, is 2, 6. In that case, it's like you are having a line and you need to find its equation. And this point here is, for example, this point is A with 2, 6. And then the gradient of this line is equal to 4. And you are being asked to find the equation of that line or a straight line. To find the equation of that straight line is just the same procedure as we have done earlier. The only difference is that the earlier one procedure, we had 2 points, after which we had to find the gradient and then we select one of the points on that straight line. The same procedure applies here, but half of it, in such a way that if you have been given the gradient and one of the point, what you need to do to find that gradient, you need 2 points on that straight line. So as to find those 2 points, you need to select one of the point on that straight line. And may it be like point, I would like to select P and have coordinate X and Y. If that is the case, then it means that if P is my selected point, to find the gradient now will be change in vertical distance or displacement over the change in horizontal displacement, which shall be referred to as gradient will be change in y over change in x, as in short form. So if that is the case, I'm going to have change in vertical displacement will be change in coordinates of p minus that of a. In that case, we are going to take the change in y coordinate of x, p. So I will select the y coordinate of p, which is y, minus the y coordinate of a, which is 6, over the x coordinate of p, which is x, minus the x coordinate of a, and the x coordinate of a is 2. But remember, I have been told if I do that, I'm going to get my value as 4. That is the gradient. So in other words, I'm required here to do what we refer to as cross multiplication. So if I do cross multiplication there, I'm going to end with, if I take this side first, I will have y minus 6 is equal to 4 into bracket x minus 2. If you cross multiply, that if is the case, then you will end up with y minus 6 is equal to 4x, if you expand the bracket, minus 8. If you need to find that line, that is the line, the equation of that line. But you can still make the y the subject by adding 6 on both sides, such that to eliminate 6 on the left hand side, So on doing that, you are going to end with y is equal to, since this one will cancel out, and you remain with 4x minus 2. And that is the equation of your line of where you had been given point A and the gradient 4. So that is how you will find, in case you have a line and on that line you have only been issued with a gradient and you have been issued with the one of the coordinates, such that not one of the coordinates but one of the points. So that if in the case, that's how you can compute it. You will encounter some of the problems or mathematical problems and pertaining the same situation we are doing here, and you will use the same approach to handle those problems. Now we are going to learn more about that is linear equations. That is linear equations. And linear equations in most cases are in the form of y equals to mx plus c. Here you will find that you will have some of the equations of straight line which are not in the linear equation, and sometimes you are being required to form them into linear or to put them into linear equation form. And if you are required to put an equation into linear equation form, it's just simply rewriting it into the form of y equals to mx plus c, in such a way that if you have an equation such as 4x plus 3y equals to negative 8, this equation can be rewritten into linear equation because this is a mixed up, and you can write it into linear equation in form of y equals to mx plus c, and be in a form that you want to make y the subject. If that is the case, this one here will be written as, first thing, you have to subtract 4x from both sides, such that you will have eliminated 4x on left hand side, such that this one will cancel itself out and will remain with 3y is equal to negative 4x minus 8. You will end up with that. But remember, we need that one to be in a form of y equals to mx plus c. If that's the case, then to have y as the subject, you need to divide both sides by 3, so as to remain with y is equal to negative 4 over 3x minus 8 over 3. You can simplify it further, this one, by leaving it in a mixed fraction, but if you leave it in improper fraction as it is, there is no problem. So this equation here, it is in the form of y equals to mx plus c, whereby, as you can view at that point, y is this total here is the equation itself, but negative 4 over 3 there is what I'm referring to m, and that one here is now our gradient, is something corresponding to gradient. So meaning that the remaining negative 8 over 3 is equal to c. And that c is what we shall refer to later as y-intercept. But that one we shall see it later. So meaning that if you have an equation of this sort, then it means y equals to mx plus c. If you are required to find the gradient, you just take the coefficient of x. And the coefficient of x will give you the gradient, as we can see from what we have worked it out. You will find out that in most cases you will be given some of the equations, and most of them may have negative gradient, others will be having positive gradients, but so long as you rearrange them into the way or the form of linear equation, you will find that to find m will be simple, and most of them will be differentiating from each other because of the value of m. Now let's see how we can find y-intercept or x-intercept. If you have a Cartesian plane maybe of this sort, and you have a line maybe running from that direction to there, and having a certain, maybe let's say an equation y equals to mx plus c. Then from this line here, you will identify that, as we have said, m is the gradient, but on addition to that, we have a point which cuts the y-axis. If this one is the y-axis, we have a point which cuts the y-axis and a point on which the line cuts the x-axis, for this our case here, for this line here. So you will find out that at this point here is what I will refer to as y-intercept. So meaning that y-intercept is a point on which a graph or a straight line cuts the y-axis, and x-axis, which I will refer to is at a point of like this, is a point in which a given line or a given straight line of a certain equation cuts the x-axis. At this point, y is equal to 0, and at this point, x is equal to 0. If you have that as your equation, y equals to mx plus c, c here we always represents the point at which that equation cuts the y-axis. That's why we refer to it as y-intercept. Let's view it in an equation and see how we can demonstrate it in an equation. For example, we have y equals to 3x plus 2. We have y equals to 3x plus 2. In that case, from the equation there, we can identify the y-intercept and x-intercept by, since we have said here x equals to 0, you can replace where the x is by the value of 0. So you can say y equals to 3 multiplied by 0 plus 2, and you will find that y-intercept is equal to 2, which we had already said there. So meaning, if this was our line, then this one here will be at 2. But if you want to find the x-intercept, x-intercept can be found by replacing the value of y by 0. So if that is the case, you will say that where y is, you place 0 and 3x plus 2 will remain. So if that is the case, you will find that your x-intercept will be equal to 3x equals to negative 2. If you want the value of x, you divide both sides by 3, and you will find that x-intercept, according to the equation, is equal to negative 2 over 3. So that is how we do determine the x and y-intercept of given line. But can also be just identified in case an equation is in the form of y equals to mx plus c. You can easily identify the value of y-intercept or the value of c by replacing x by 0, and also identify the x-intercept by replacing y by 0. Let's see an example on the same, and the example reads: find the equation of a line whose x-intercept is negative 3 and y-intercept is 6. So we have x-intercept, meaning that is the point where the line cuts the x-axis, and we are being issued with negative 3, and the point where the line cuts the y-axis, we have been told, is 6. So meaning that the coordinates of that line is, for the case of x-intercept, will be negative 3, 0, and at y-intercept will be 0, 6. So if you have been told to find the equation of that line, the first thing you need to do, you have to find the gradient of that given line. And finding the gradient, we say the gradient can only be found by taking the change in y over change in x. So if that is the case, we shall start with the next point, which is 0, 6, and take 6 minus that of the first point, which is 0, over 0 minus 3. and you will find out that we are going to have 6/3, which is equal to 2. So meaning the gradient of that line will be equal to 2. If you have a difficulty in identifying, you can name this point which has the x-intercept as point A and this one as point B, in such a way that it will help you to find the gradient of that equation. So if that is the case, we are going to have the equation of that line has a gradient of 2. So to find the equation of that line, we need to identify one point on the line which is not A or B. So we can select point Q which has the coordinate xy. If that is the case, we can choose Q and A or Q and B. So let's take Q and A. So we can say that to find the gradient, which is 2, is found by changing y over changing x. So shall it be change in y will be now that of y which is q, which is y minus 0. I select A over here we have x minus, there is minus 3, the coordinate of A. So in that case, we are going to end up with y, because y minus 0 is just y equals to 2x. Now minus 3 will be positive, so it will be plus 6. And this is the equation of that given line. Now let's work out the graph of a straight line. In this case, you have been informed that this is 4.4. You have been informed that draw the graph of a line passing through 0, -4, and has a gradient of 2. Draw a graph passing through that point and has a gradient of 2. What you need to do here first is to identify the equation of that given line. So what you need, you will have to select one more additional point that is on that line, and when you calculate the gradient, you will find that gradient is 2. So we can choose point Q with the coordinate x and y in such a way that if we compute the gradient, which is changing x over changing y, changing y over changing x, we shall have it as that y coordinate of Q minus y coordinate of this point, let's call it point A. So that will be minus 4. And then the x coordinate of point Q minus the x coordinate of point A will give us 2, because that is our gradient. So if we work out that way, we are going to have, if we cross multiply, we shall end up with y plus 4 is equal to 2x. And on further computation, we are going to find that if we need y to be the subject, we shall subtract 4 on both sides, and we shall have 2x minus 4. Because on the left hand side, it will cancel itself. So we are going to have y equals to 2x minus 4. If that is the case, now we can draw a graph of this given equation, which has a gradient of 2 and passes through point A of 0, -4, and x and qx, y. Since we have here, we can construct it in 2 ways. The first way, you can first find the y-intercept, and y-intercept there you have is 0, -4, and then you find the x-intercept, and x-intercept should be found from this equation, in that you replace y with 0 and you find out what is x. So if that is the case, you are going to have 4 equals to 2x. If you divide by 2 in order to find the value of x, you are going to find that x is equal to 2, since that is the x-intercept. So meaning this x-intercept will be 2, 0. Now you can construct a Cartesian plane whereby this is 1, 2, 3, 4, 5, 6, and this is x-intercept, x-axis, and this is y. You can have a Cartesian plane of that, like mine is a sketch, and on this sketch you can just plot the y-intercept and the x-intercept. And if that is the case, you will find out that the x-intercept is at this point. So if we plot, we shall find that way. And the y-intercept, we are having it at this point here. So what you do next after plotting that, you join the 2 points with a straight line. So that is a pen and a ruler. You will find a straight line passing through the 2 points. And that straight line there is our equation which we are seeking, which is y equals to 2x minus 4. That is the first method of drawing that one, that straight line, or that equation of a straight line. But mostly that's the best advised method. But you can still work out the corresponding values of x to the corresponding values of y to chosen values of x in such a way that since we have the equation of the line as y equals to 2x minus 4, you can work out the corresponding values of y to each chosen value of x in such that if you choose x to be, let's say, 0, y here will be negative 4. If it is 1, you are going to have y as negative 2. If it is 2, you will have y as 0. If it's 3, you will have y as 2. And if it is 4, you will have y as 4. So on drawing, you will find that you are going to plot these points on this Cartesian plane, and they will still merge through the straight line you have constructed, in that 0, negative 4 will lie here, 1, negative 2, 1, negative 2. So as we can see, you will find it will lie at this point here, and then 2, 0, you can see where it lies, 3, 2, 3, 2. So it is on this line here, that is my 3, 2 here, and 4, 4 will be at a point here. As according to, if you draw it to a scale, you will find 4, 4 will be at that point. So that is how we do draw. The best way is just to find the y-intercept and x-intercept, and then you join the two and construct that straight line. With the same knowledge, I believe you can still construct any given values of 1 point and gradient of a straight line, and you'll be told to draw that straight line on a graph. What you just need to do is select a suitable scale for what you have to work, and then you find the equation of that line you need to work it out. Find the y-intercept and the x-intercept. Plot the points on the Cartesian plane. Join the points using a straight line, and you will have constructed your graph. Under perpendicular lines, you will find that in case you have a Cartesian plane of this sort, you will find there some lines running in different directions. You may find one line run that way, another one cuts it at 90 degrees, but it's still a straight line. Maybe another one may cut it at that point and is still at 90 degrees. We may have another line which passes this way, and another line cuts that point at that line. So let's call this one A, this B, then this one C, D, and E. Let's have this as E. So you will find that line E is perpendicular to line C. We can abbreviate it as this. So line E here, as we can see, E is passing this way, but cuts line C perpendicular at this point. So you will find it is perpendicular to line C, and also line C is perpendicular to this line D. But you can see line A, which is this one here. Line A passes here, but cuts this line B perpendicular at this point. So that line there, we can say A is perpendicular to line B. From there we can see that if two lines cut each other at 90 degrees, we do say those lines are perpendicular to each other. What happens to those equations of their lines? You will find out that in case you compute, you have been given the equation of this line. For example, if this one is y equals to mx plus c, and this one here which it cuts is y equals to negative mx plus c, you will find out that if you compute the gradient of this and the gradient of that, you will find out that they are equal to negative 1. So that means that the gradient or the perpendicular lines, if the product of the gradient of two lines is equal to negative 1, then the two lines are said to be perpendicular to each other. For this case, if I take the product of the first gradient, which we may take the line as D, so that is M, I multiply to the gradient of line C, which is negative M, I should get the answer as negative 1. That is what it says. So this is what will be leading us, that M1 multiplied by M2, in case, let's just say this is the gradient M2 and this is M1. So if I take the first gradient of the first line, I multiply to the gradient of the second line of two different lines that cuts each other perpendicular, you should get the value as negative 1. Let's see it in computation of our analysis here. Which of the following lines is perpendicular to the line y equals to 4x plus 2? Y equals to 4x plus 2. So we have line A, you have been given is y equals to a half minus a quarter x. And line 2 is y equals to 4x plus line 2, which we may call B, equals to y is y plus 4x equals to 6. So what we need to do here is just to identify what we have. So we need to identify which of the two lines here is perpendicular to line y equals to 4x plus 2. But remember, we have said, in case two lines to be perpendicular to each other, the product of their gradient must be equal to negative 1. So meaning that if we take M1, we multiply by M2, we should get the gradient equal to negative 1. For this case, you can see this equation here is in full linear equation. It is in its simplest form, so we call it linear equation. The same applies to this, is in linear equation. But if we work it out, you can see, let's take the gradient of the first equation. Our equation here has a gradient here is in the form of mx plus c. So the gradient here is 4. M equals to 4. And in A here, M is equal to this one. This is C. This is negative mx. So meaning M here is equal to, so we can just take M here is equal to negative a quarter. That is the coefficient of x. And here, M in the equation B is equal to, first you need to rearrange this. This is not in the form y equals to mx plus c. What you need is first to rearrange it into form of y equals to mx plus c. So that we may have y equals to, now you take this one to the other side, will be negative 4x plus 6. That's what you will have. So meaning that M there is going to be m is equal to the coefficient of x, which is -4. So let's compute out and see. If we take m1, we multiply to m2, we should get -1. What about this, our equation here, and equation A? You will find out that if we take m1, which is now 4, we multiply by equation 2, or equation A, which is -4, -1/4, we are going to find 4 here, 1, 4 here, 1. 1 times -1, you will find -1. So meaning these equations are perpendicular to each other. But in case of the other one, we have this equation here, and m is equal to 4 for the first one. If we multiply it by equation B, gradient of equation B is -4. We are going to have -16. -16 is not equal to -1. So meaning that the two equations are not parallel to each other. So this one is odd one out. So equation A is perpendicular to this equation here. So we can say that this equation is not perpendicular to this equation, but equation A is perpendicular to our equation there. So if we compute out, we can find out that 4 multiplied by -4, we are getting -16, which is not equal to -1, and that means that that equation is not perpendicular to our given equation there. So that is how we do compute out equation of a given line, and we can find the perpendicularity in them. And if they're not perpendicular, you will identify them by multiplying their gradient so as to find -1. If they doesn't comply, then they are not perpendicular to each other. Sometimes you may be given the gradient of one of the equation and one point of the other equation, and you'll be told to find the equation passing, or to find the point, a certain point on that equation. The same apply, just use the same technique and what we have learned and find the equation of that line. So I believe you have no difficulties to identify and also calculating equations which are perpendicular to each other. In case you need to identify parallel lines here, you will find out that the parallel lines are equations or lines which have the same gradient. They may have different kind of y-intercept, but the gradient be the same. Whereby, if you find any two equation or three made before with the same gradient, then those lines, if drawn on a Cartesian plane to scale, you'll always find that they have the same gradient, and meaning that they will be parallel to each other. For instance, we can view out a line like y equals to a half x plus 7, and another one is equal to y equals to a half x minus 20. If these two lines are being drawn on a Cartesian plane, or just on identifying without drawing it down, you will find out that considering the equation of linear equation, which is y equals to mx plus c, we did say that m is representing the gradient in such a way that for this case here, our gradient will be the coefficient of x here and is always m. So here the gradient is a half and here is a half. That implies that these two equations here, if drawn on a Cartesian plane, you will find they are parallel to each other. So meaning that equation 1 here and equation 2 are parallel to each other. And that is how we do identify. It doesn't require much more skills. So long as you identify the gradient of the respective lines, you will identify if they are parallel or not. If the gradient is not issued and the points are issued, then you will calculate the gradient and compare the two gradient of the two equations, or 3 or 4, so long as you are being provided with a several of it, and see if they are equal to each other, and you will identify that they are parallel. If the gradient are equal, they are parallel. If not, the lines are not parallel. With that, I have come to the end of our topic today. I believe the lesson has been much more interesting. See you in our next videos.